morning, everyone. So, today I'll continue the lecture on carburetor of an SI engine. Okay. So, last day we have seen the components of a simple carburetor and what is the theory followed in the carburetor. Okay. Now, today we'll go to the basic calculation of carburetor and then we'll see the modification, the modified carburetor which are used in the recent times. So, let us start with that. So last day I have told you the basic components and the mixture. Okay. Now we'll start with the calculation of this. So this is the diagram for a simple carburetor. A simple carburetor का एक diagram है. So here we have taken. So you know all the components. So you know all the components. So here we have taken a two portion. In the portion one and another section is 2. The section 2 is at the throat of uh, the venturi. Okay, and the height, because the nozzle is a little bit greater height than your your the fuel level in the fluid chamber, and that is given by Z. So we will see the air fuel ratio, the calculation of air fuel ratio for different conditions. So first we will consider the air is an compressible fluid. Okay, so if the air is a compressible fluid, then we will do the calculation. Okay, so we'll take the section 1 and 2, and we'll use the steady flow energy equation. Okay, so if we use the steady flow energy equation, then it will come is like this: Q minus W is equal to H2 minus H1 plus half of C2 square minus C1 square. Okay, so as the air is only flowing and the mixture is producing, that means there is no heat transfer as well as there is no work transfer. So Q is equal to 0 as well as W is equal to 0. Now the inlet velocity of the air with respect to the venturi velocity is very much less. So we can consider C1 is almost 0. So C1 is almost 0. So if we put all this value in these equations, if we put all this value in this equation, so C2 will come 2 into H1 minus H2. Again, we know H is equal to Cp into T. Okay, so H1 will be Cpt1 and H2 will be Cpt2. So if we take a common Cp that means the heat capacity at constant pressure. Okay, so it will come to Cp T1 minus T2. T1 minus T2. Now, as from process 1 to 2, there is no heat transfer. That means we can consider that the process in is an adiabatic process. So if it is an adiabatic process, that means we can use this formula T2 by T1 T2 by T1 is equal to T2 by P1 to the power gamma minus 1 by gamma, and you know how this equation comes. Okay, so T1 minus T2 will be this. So T1 minus T2 will be this. T1 multiplied by bracket 1 minus P2 by P1 to the power gamma minus 1. Okay, so T1 minus T2 आ गया ये. So we will put this T1 minus T2 value over here. इधर put करेंगे. So if we put the value of T1 minus T2 over there, we will get the equation like this: C2 is equal to 2 Cp T1 multiplied by 1 minus P2 by P1 over gamma minus 1 by gamma. Okay. Now we have to, because we are finding out the air fuel ratio, so we have to find what is the mass of the air flowing. That means the mass flow rate of air. So mass air का mass flow rate निकालना है. So अगर हम continuity equation use करते हैं, so if we use the continuity equation, we'll get as rho a c1 is equal to rho a2 c2. So rho a1 c1 is equal to rho a2 c2. Okay, so rho a2 c2. Okay, so we will stick to this rho a2 c2 because we have got the value of c2. Okay, so if we use the formula for adiabatic process again, we will see that p1 v1 to the power gamma is equal to p2 v2 to the power gamma. Okay, v means 1 by rho. V means this is a specific volume, so we know specific volume is a reciprocal of the density, the mass density of the fluid, or vice versa. That means the mass density of the fluid, the reciprocal of your specific volume. So if we can put uh, 1 by rho 1 with respect to v. Okay, so if we put this, we will get the value like this: p1 by rho 1 to the power gamma is equal to p2 to the by rho 2 to the power gamma. Okay, so P2, rho 2 will come, so rho 2 will come P2 by P1 to the power 1 by gamma multiplied by rho 1. Rho 2 will come P2 by P1 to the power 1 by gamma multiplied by rho 1. So now we will put all the values of rho 2 and C2 on this equation. So M dot A will come rho 2, that is P2 by P1 to the power 1 by gamma multiplied by rho 1 into A2 into C2, and C2 we have got the value like this. So we have put all the values of this over here. So we have put the value of rho 2. Hello, hello, আমি ক্লাসে আছি এখন, একটু পরে ফোন কর, আধা ঘন্টা পরে। 23 জন জয়েন করেছে, তুই চেষ্টা কর, ওই যে লিঙ্কটা দিয়েছি ওই লিঙ্কটা দিয়ে চেষ্টা কর, তাহলে জয়েন হয়ে যাবে। Okay, so m dot a is equal to p2 by p1 to the power 1 by gamma multiplied by rho 1 into a2 under root of 2 cp t1 into 1 minus p2 by p1 to the power gamma minus 1 by gamma. Okay, so what is m dot a? मतलब जो mass flow rate है वो क्या होगा? So it will come like this. So we will put the value of rho 1 because we know pv is equal to rt. Okay, so in terms of v we can put p by rho. So rho will come p by rt, p by rt. So in terms of rho 1 we'll put p1 by rt1. Okay, then we have a2, so we'll put a2, and then we'll take out this t1 out of the equation. So if we take t1 out of the equation, that means under root t1 will come out of the equation. So t1 or either head t1. So if we do the simplification, it will come in the denominator, it is under root of t1. So p1 a2 by r into t1 multiplied by 2 cp and the rest. So we have put inside the P2 by P1 term 1 by or to the power 1 by gamma. So do the calculation by your hand. So it will be quite easier to understand. Okay, so I just show you the steps. Okay, then we'll put the value of all the things because we know that the an IC engine or spark ignition engine use air. So we'll put the specific heats at constant volume pressure as well as gamma as well as R. The value of this, it will come in terms of your air. So the specific heat at constant pressure of air is 1.005 kilojoule per kg Kelvin. Gamma is equal to 1.4, R is equal to 0.287 kilojoule per kg Kelvin. So if we put all these values on the previous equation, that means this equation, if we put all these values in this equation, the equation will come like this: m dot f is equal to 0.1562 multiplied by a2 p1 by t under root t1 by the rest. ओके, so this rest, ये जो बाकी का जो चीज है, प्रेशर का जो ये है, हम इसको पकड़ लेंगे 5, हम इसको पकड़ लेंगे 5. ओके, so m dot a is equal to simplified, it will come 0.1562 multiplied by a2 p1 by under root t1 into 5. So 5 का value already I have told what is 5. Okay, now this is the theoretical mass flow rate, but we are using venturi, so we know that for the actual cases we have to consider some correction factors, or we have to put some correction. Okay, and what correction we do, that is the coefficient of discharge, because the velocity you are considering, so you have to use your fluid mechanics concept and you have to put the coefficient of discharge value. So look at over there, the coefficient of discharge value is provided, that is cd1, this cd1, cda. CDA means the coefficient of discharge for air. Okay, so we have got the actual air flow rate, the actual air flow rate in terms of mass like this. So this is a very much important equation. This is a very much important equation. Okay, next, for the fuel. So we'll find out for the fuel. Now, as the fuel is flowing, as the fluid is flowing through the nozzle, and we have a float chamber, so the fluid is there, so we will use the Bernoulli's equation. So you know Bernoulli's equation, there is a pressure head, velocity head, and the datum head. The summation of all these remains constant. So if we use the mm, Bernoulli's equation and we neglect the lower value terms, then this will come, because we will use this in terms of fuel, that is 2, and here it is 1, because this 1 is open to the atmosphere, since this vent is open to the atmosphere, so we will consider this 1 term as well as in the fluid level also. Okay, so if we put all these things, we will get like this: p1 by rho f minus p2 by rho f is equal to cf square. मतलब cf square है the fluid the velocity of the fuel at the tip of the nozzle, because we are considering the tip of the nozzle and the two portion. Okay, so tip of the nozzle and the two portion, so it will come the p1 by rho f minus p2 by rho f is equal to cf1 cf square by 2 plus gz. Okay, so cf will come like this. So cf will come like this. Again, we will use the formula for mass flow rate, that is the rho f, af and cf. Af is the diameter, af is the area of the nozzle. Then the equation, if we put the value of cf over here, the equation will come like this. Okay, so for the actual cases, we have to multiply it with the coefficient of discharge for the fuel, so the cdf multiplied by rho f into af and the rest. So these things are manipulated. Do it by your hand, you will able to understand. Just see the lecture once again. Okay, and do it by your hand. Okay, so you will able to understand step by step. Okay, अभी मैं जो बोल रहा हूँ वो अगर तुम कॉपी पे नहीं करोगे तो you will not able to get the steps I am telling. So do it by your hand, then it will be clear to you, very much clear to you. Okay, so what will be the air fuel ratio? So it is the mf ma, it is the ma mass of air by mf, which is like this, so ma we have got over here, we will put the value over there, and mf we have got the value over here, and we'll put this equation over there, and if we manipulate it, the final equation will come like this. Okay, so this is the air fuel ratio if the air is considered to be compressible. Okay, now we put some conditions and try to simplify the equation, that will help you in terms of GATE as well as in terms of some competitive examinations. Okay, so first is the air fuel ratio neglecting the compressibility of air. Matlab, the air is now considered to be an incompressible fluid. So if the air is an incompressible fluid, that means there is no variation of rho, मतलब density का कोई variation नहीं है. So we don't have to use the steady flow energy equation, मतलब temperature को इधर आने का लाने का कोई जरूरत है ही नहीं. So what we will do, we will put the again the Bernoulli's equations. So if we put the Bernoulli's equations and we neglect the lower order values, that is the inlet air velocity, that is zero almost, I have told earlier. So if we put these things, if we neglect all these things and we use the Bernoulli's equation, we'll get the formula like this: C2 is equal to 2 into P1 minus P2 by rho A. So MA will be coefficient of discharge multiplied by rho A into A2 into, that is rho A C2. So it will come like this. So what will be MA by MF? That is the air fuel ratio. It is CDA by CDF, CDA by CDF into A2 AF. Now we can ask me one question, sir. Where you will getting the MF? MF we are getting over here. MF we are getting over here. Here. Here we are getting MF because we are already considering that the fuel is an incompressible fluid. So ये फ्यूल का जो कैलकुलेशन है वो हम इनकम्प्रेसिबल फ्लूइड के हिसाब से कर चुका हूँ, लेकिन अभी जो कर रहा हूँ दैट इज वी आर कंसिडरिंग द एयर टू बी इनकम्प्रेसिबल. Okay, so if we consider these things, the equation will come like this: CDA by CDF into A2 by AF multiplied by under root of rho A P2 P1 minus P2 by rho A P1 minus P2 into minus rho F G Z. Okay. Now if we consider that if Z is equal to 0, मतलब इसका कोई elevation है ही नहीं, इसका कोई elevation है ही नहीं, इधर no elevation is there. If there is no elevation, then what we can consider that this Z will be 0. This Z will be 0. So if this Z will be 0, it will come P1 minus P2. So it will be cut out. If we consider Z as 0, if we consider Z as 0, okay. So the equation will simply come M dot A by M dot F is equal to CDA by CDF into A2 by A multiplied by rho A by rho F. You must remember this equation because this is very much important. It is a simple equation and you must remember. Okay, so we have done the calculation of simple carburetor. Now we have to see what are the disadvantages of carburetor. The main carburetor disadvantage is its metering and the maintaining the air fuel ratio. Because if you want to maintain the air fuel ratio, we have to change the throttle position, because one certain throttle position gives you एक certain throttle position तुमको एक ही air fuel mixture देता है. Okay, so that's why that is the main disadvantage of it, and because of this the efficiency, the overall efficiency of an IC engine is reduces. Okay, so how to improve the efficiency? So to improve the efficiency, we have to go for the injection system. Okay, so if we produce the injection system, it will produce a greater economy. Thus, the atomization produces more in a homogeneous mixture, and as well as the efficiency of the cycle increases. Okay, now we'll see how many types of fuel injections are there. The classification of fuel injection. Okay, so first the fuel injection is classified in terms of injection mode. तो कौन सा इंजेक्शन मोड है? So basically there are two types of injection mode: direct type injection mode, port type injection mode. Now if it is a port type injection mode, then how it is classified? So it is a single point or throttle body injection mode, or it is a multiple multi-point fuel injection, MPFI. You have heard the term MPFI. This is the MPFI, multi-point fuel injection. Okay, then last one comes the according to the type of activation, that is mechanically activated or hydraulically activated, and the last one is electronic injection system or ECU, electronics control unit. Okay, now we will see the example of one by one. So first is direct type fuel injection. So you can see it is almost similar to the diesel cycle injection type. That means the fuel is directly injected in the fuel is directly injected into the cylinder. So this is known as the direct type fuel injection. Now port type fuel injection, it means that injection is done on the intake manifold. जो हम लोगों का intake manifold है, जो अंदर आ रहा है in the combustion chamber by the opening of your valve, inlet valve. So जो हम लोग का जो इनलेट मैनिफोल्ड होगा, इनलेट मैनिफोल्ड से फ्यूल को इंजेक्ट किया जाता है, so that is known as the port type of injection, port type of fuel injection. Okay, then comes the single point or throttle body injection. So single point throttle body injection मतलब it is applicable for the multi cylinder engine. मतलब अगर multi cylinder engine है, so हम एक बारी fuel mix करेंगे and we will send it to the several cylinder. So look at over there. So the air is coming and one throttle body is given. One throttle body is given. That throttle body is basically injecting the fuel. ये जो throttle body है, fuel को inject कर रहा है. That means it is making the air fuel mixture, and that air fuel mixture here is a throttle valve is there, which is controlling the flow rate. And the air is flowing like this, and it is going inside the cylinder. मतलब एक ही पोर्ट है जो पोर्ट से एयर को मिक्स किया जाता है, एयर फ्यूल को मिक्स किया जाता है एयर के साथ, देन ए थ्रॉटल बॉडी व्हिच कंट्रोल्स द फ्लो रेट ऑफ एयर, एंड दैट एयर, द मिक्सचर ऑफ एयर इज सेंट टू द नंबर ऑफ सिलेंडर्स. ओके, नाउ नेक्स्ट है मल्टी पॉइंट फ्यूल इंजेक्शन. So multi-point fuel injection is very much important because multiple fuel injection is generally used nowadays. Okay, so what is multi-point fuel injection? So as the name implies, so if it is a single point, that means the fuel injection was done by a single body, a single throttle body. But here the fuel injection is done by several fuel injector. Okay, how? So before entering into the cylinder, each cylinder each cylinder has a injector at the just at the entrance of the cylinder, just at the entrance of the cylinder. Okay, so air is controlled by a throttle valve, and the air is coming, okay, so here is the fuel injector which will inject the fuel. So for every portion, for every multi-cylinder engine, for every cylinder, just one injector. So that's why it is known as the multi-point fuel injector. Okay, so it is directly fuel is directly discharged into the cylinder. Okay, next है जो last one है, that is the mechanical injection type. So type of fuel injection, so one is mechanical injection type, another is electronical injection type. Okay, so here it has been shown the diagram of mechanical injection system. So it is a single point fuel injection. You must remember it is a single point fuel injection, and you can see that a mechanical type of injection system is shown. So क्या है? So let me show you. Let me tell you. So इधर है एक mechanical plunge, then इधर है एक spindle, then it is the solenoid. It is a solenoid that is to be excited from the outer resource. Okay, then it is a fuel, the inlet of the fuel. So whenever this mechanical injection system is inoperative, मतलब कोई जब कोई ऑपरेशन नहीं है, मतलब साइकिल में जब फ्यूल का जरूरत नहीं है, so that valve will go in the downward direction. So that valve will go in the downward direction, and it will block the passage of the fuel. It will block the passage of the fuel. Okay, so that the fuel should not mix with the air and it should not go in the intake manifold. Okay, now whenever the fuel is required for the cylinder and the timing is set, the timings are set by some control unit, and if the time is set, then what happens, this solenoid valves, at least this magnetic coils excited, and because of this magnetic coil exciting the magnetic plunge uh, goes in the upward directions, or rather you can say the solenoid pulls the magnetic plunge. So as the magnetic plunge is goes in the upward directions, so the spindle will left the clogged portion, and it will go in the upward directions, and it will make a passage for the flow of the fuel. So as the flow of the fuel, as the plunge, so as the plant will go in the upward direction, so the plant upward direction पे जाएगा, so ये जो passage है ये खोल जाए, खुला हो जाएगा. अगर ये खुल गया, so the fuel that is over there, so it will be goes in the directions, and atomize, we will get an atomized phase, because at the tip of that system there is a nozzle, so nozzle will make the system to spray on that entrance of the air, okay, and will make a mixture. So this is the main types of mechanical injection system, okay. And here are we shown, that is the time with respect to the fuel injection, okay. So whenever the fuel is not whenever the fuel is not injecting, so it is inoperative conditions, so the solenoids are in operative conditions, then the solenoid has started, the solenoid has started working. Whenever the timing is come, don't jab timing aa jayega, so solenoid will start come, and at that time it will it will make it will be at the topmost position of the topmost position, मतलब ये सबसे ज्यादा ऊपर रहेगा, so that the fuel injection occurs. Then फिर से टाइमिंग अगर खत्म, जब खत्म होता है, तो solenoid valve डिस्चार्ज होना शुरू हो जाएगा, मतलब वो प्लांट को नीचे दे देगा, because there is a helical spring which will pull the plant in the downward direction. So ये डाउनवर्ड डायरेक्शन पे चल जाएगा, okay, and will again clog the passage of the flow. Okay, so this is the timing of the mechanical injection system or the solid injection system, and the injection time here it has been given, that is 1.5 to 10 milliseconds, so it is per the as per the requirement, okay. And the movement of the spindle is given 0.1 to 0.15, और जो spindle का movement है, ऊपर नीचे जो movement है, that is restricted from 0.1 to 0.15 millimeter, and the injection जो time है, that is 1.5 to 10 millisecond, okay. So last one comes the electronic injection system. So electronic injection system में क्या होता है, एक fuel pressurized किया जाता है, just like your is compression ignition engine fuel supply, so pressurized fuel supply रहता है, and electronic control electrical input होता है उसका, and एक electronic circuit रहता है. So I will give you the total circuit in your WhatsApp group, okay. The what the circuit looks like, that is a little bit complicated, so I will give you the circuit diagram, and I will just go through it. So the electrical input is given. So there is the electronic control unit which controls the flow rate of the fuel. So it is more modified and more costly. But here the fuel economy is very much higher, because you can see, तुम देख सकते हो कि अगर हम इलेक्ट्रॉनिक्स कंट्रोल बोर्ड यूज करते हैं, सो इट विल वेरी, दैट मीन्स द फ्यूल का जो फ्लो रेट है, दैट विल वेरी विद रिस्पेक्ट टू द changes in the load, or with respect to the variation with load, बहुत प्रिसाइजली ये होगा, मतलब जो फ्यूल इकोनॉमी होगा वो बहुत अच्छा होगा, okay. So then it is then after controlled by the ECU, which has an electrical input, it goes to the regulated fuel supply, okay. So this is the concept of electronic fuel injection system. And let me tell you one thing: the electronic injection system is it is not only controls, it not only controls your only fuel injection, because the fuel flow rate, जो fuel flow rate है, ये सिर्फ लोड के हिसाब से वैरी नहीं होता, ये इलेक्ट्रॉनिक्स कंट्रोल यूनिट सब कुछ देखता है कि इसका कूलिंग कैसा हो रहा है, ये जो लोड है, ये जो सिलेंडर वॉल का जो टेम्परेचर वो कैसा है, मतलब सब कुछ एक साथ देख के एक लॉजिक बनाता है, लॉजिक बनाने के बाद कितना फ्यूल सप्लाई होना चाहिए, इट विल सेट दैट अमाउंट ऑफ फ्यूल, सो इट्स वेरी मच प्रिसाइज. It is a costly thing, but the fuel economy is very much higher, okay. So with this I will complete my lecture on carburation, okay. So if you have any question, then you can ask me, okay. Any question, any question? कितु सर आपके कोनो क्वेश्चन नहीं? Okay, so I will complete this lecture over here, and I will provide you the uh, notes of electronics control unit or injection, so you will just go through it, okay. So thank you and goodbye.